Algebra 2, Unit 3, Lesson 1, Solving Equations. In this lesson, we want to solve one-variable linear equations and rewrite formulas in terms of other variables. So I'll remind you that solutions are any value that makes an equation or inequality true. If it doesn't make the inequality true or it makes it false, it's not a solution. An equivalent equation is one that has the same solution set. So if you can do different things to an equation and it gives you the same solution set, the first one and the second one are called equivalent. So which things can give us equivalent equations? There's the reflexive property in which 2 equals 2. So I know that one number equals itself or a variable equals itself. The symmetric property where I can switch sides. So if I have written 2 equals x, I know that x equals 2. There's the transitive property. If a equals b, and then that second term b is equal to a third term, then the first and third ones are also equal. The addition property, subtraction, multiplication, and division properties will be our primary properties. If you have a equals b, then you can add the same number to both sides, and they will be equivalent. You can subtract the same number from both sides, and this will be equivalent. You can multiply both sides by the same number, and they will both be equivalent. You can divide by the same number on both sides as long as you're not trying to divide by 0. And finally, if a is equal to b, wherever we see a, we can substitute b instead of that a. So which of the properties are we using here? 4 equals x minus 3, we can rewrite as x minus 3 equals 4. We're swapping sides. This is the symmetric property. You should fill in these properties as we go. This is the symmetric property. If we know x equals y, then if z equals 4x plus 3, then we know z equals 4y plus 3. Well, instead of this x, all we've done is substitute y. That's the substitution property. Given x equals y plus 3, and then y plus 3 equals 2x plus 4, then we know x is equal to 2x plus 4. The first is equal to the second, and the second is equal to the third. Then we know the first and thirds are equal. That's the transitive property. We're going to use different properties of equations, again, mostly the symmetric, the addition, and then substitution later to solve equations. So when you have an equation that you want to solve, you need to get all of your variable terms on one side and all of the separate numbers on the other side. So we can first subtract 3w from both sides, will give us 4w. Then we can subtract 2 from both sides, will give us 92. Then we're going to divide both sides by 4. 92 divided by 4 is 23. If you check and put 23 in here and 23 in here, you should get the same thing on both sides of that equation. Here we have 10 times y minus 2y equals minus 5 times the quantity 2y minus 1. You can distribute your numbers to both of them first. 10 times 1 is 10, 10 times minus 2y minus 20y, and here minus 10y and plus 5. Then again, all your variable terms need to go to one side, all your separate numbers to the other. Typically, people take their variables to the left and the numbers to the right. Makes a lot more sense when our variables on the left, but sometimes you take them to the right and then later on you'll switch them. So we're going to add 10y to both sides. This one will cancel on the side. Here we'll be left with minus 10y. Then I'm going to subtract 10 from both sides. That will give me minus 5. If I divide both sides by minus 10, that will give me y is equal to 1/2. To rewrite formulas, we're going to treat all of the variables like numbers except the one we're solving for. So in this, we have v equals 1/2 gt squared, which is the velocity of an object in free fall. And I want to solve for g. Well, the 2 is a number. How can I get rid of a half? I can just multiply 2 by both sides, or divide by a half. Dividing by a half, same as multiplying by 2. So if I multiply by 2, the half will go away, and I'll have 2v is equal to gt squared. And t squared is just some number. Divide both sides by t squared, and you'll get g is 2v over t squared. Of course, we can't divide by 0, so t can't be 0. ax plus bx equals c. We can only have x in one place, so you need to treat these like terms. You're going to factor out the x and get a plus bx is equal to c. And then we need to divide by the a plus b, and we'll get c equals a plus b, where a plus b can't be 0, so a can't be negative b. If there had been x's on this side, we would have taken all the x's to one side. If there had been non-x terms here, we would have taken them to the other side. So now we want to write and solve equations and inequalities. Anytime we do this, I'm going to ask you to write 4 things. First, you have to tell me what your variables are. So you're going to define your variables. You mean you're going to write the letter and then tell me in words what that variable represents. Then you have to write your equation or inequality. The variable should not be on a side by itself. We're not solving the equation or inequality that are ahead. We're writing the equation or inequality based on the information that we were given. Then we're going to use algebraic methods to solve that and then write our answer in words. So it says the length of a rectangle is 3 centimeters greater than its width. Its perimeter is 24. What are the dimensions of the rectangle? I could have picked the width or the length as the one that we're defining in terms of W is the width, then the length it says is 3 centimeters more than that. That would be W plus 3. If I had picked the length, then the width would be the length minus 3. It really doesn't matter which way you do it as long as you define it and you tell what it is that you're using. Then we know that the perimeter of a rectangle is twice the width plus twice the length. Instead of the length, we can now substitute W plus 3. We're going to distribute these, combine like terms. We get 4W plus 6 equals 24. Subtract 6 from both sides, then divide both sides by 4, and you get W equals 4.5. Then you put that 4.5 back in the length equation. You'll get 7.5. That's our solution in numbers. Then we need to write what the answer to the question is. What are the dimensions of the rectangle? The rectangle's length is 7.5 centimeters and the width is 4.5 centimeters. Or you could say the rectangle is 7.5 centimeters by 4.5 centimeters. The sides of a rectangle are in a ratio of 3 to 2. What is the length of each side if the perimeter is 30 centimeters? One thing about ratios, we know that if it's in that ratio, the actual ratio has to be a multiple of that. So whenever we have a ratio question, the variable is the unknown multiplier of that ratio of sides. So if this is x, then this 3x would be the length, and 2x would now be the width. The perimeter, again, is 2 widths and 2 lengths, so we get 2 times 3x plus 2 times 2x. Added together, that gives us 10x. It has to be 30, so x is 3. Then when I substitute, in the length I would get 9, in the width I would get 6. So the rectangle is 9 centimeters by 6 centimeters. We'll also solve distance, rate, and time problems. So in distance, rate, and time problems, we're using the equation or the relationship that the distance is the rate times the time. In our questions, there will be 2 conditions under which something happens. It could be 2 directions. It could be 2 different places you're traveling to. There have to be 2 different things. You're going to write variables for each one of those and then write your equations by taking the rate times the time equals the distance. This is simply a way of organizing your information. So we have 2 planes that left the same airport at noon. One went east and the other went west at twice the other's speed. If the planes are 2,700 miles apart in 3 hours, how fast was each flying? So we don't know what the rate of either plane was, but it says the west is twice the other, so we'll let the east be r, and then the west will be 2r. And then we don't know how far they went, so we'll let d be the distance of the east plane. So now for the east plane, its rate is r. It traveled for 3 hours, and it went a distance of d. Then the west plane, we know it went at twice the other speed, but it also traveled for 3 hours. And now how far did it go? If this one went d, and the total had to be 2,700, then the other one has to be 2,700 minus d, because if we add them and this equals b, then this other one, if I subtract d from both sides, it will be 2,700 minus d, or if you think of that, the only way for these to add to be 2,700 is if we add d and minus d, they'll cancel. Now from the east plane, we get 3r is equal to d, and then 3 times 2r, which is 6r, equals 2,700 minus d. And now this is d, 3r is d, so we can, instead of this d, we can substitute 3r. Then we're going to add 3r to both sides, get 9r is 2,700. Divide both sides by 9, r is 300. So this one is now 600. If we wanted the distance, if we put r in there as 300, the distance is 900 here, and this would be 1,800. So if they asked us the distances, we would say the east-going plane traveled 300 miles an hour and went 900 miles. The west-going plane traveled at 600 miles and went 1,800 miles.